Okay, and welcome to our first flip lesson in calculus. So today we're going to start to explore the idea of limits. In particular, today we're going to look at graphical limits using our knowledge from last day on piecewise functions. And you have seen this concept before. You've seen this concept before in advanced functions when we talked about asymptotes, when we talked about end behavior, and when we talked about tangent lines. So really at that point we were actually using limits all along, we just didn't use that terminology. Okay, so we're going to start by considering the graph of this function right here. Okay, so see if you can pause the video for a minute and remind yourself of some of your knowledge of graphing this function. So remember this function, the x plus 3 cancels out. And simply we are left with 2x minus 4. Yes, I expanded that right there. And this is, of course, a line, okay, with a hole at x equals negative 3. And the actual point where the hole is we have negative 3. And if we put negative 3 into that, then we also get negative 10. Okay, so take a minute and try to graph that line. You're going to need to use a scale of 2 for this. Okay, so we're going to start at negative 4. We're going to rise 2 and run 1, which actually means we're going to rise 4 and run 2. So it'll look something like that. And then we have our hole at negative 3, negative 10. Okay, and it's a straight line looking like that. Okay, so from MHF, okay, we would say and we would write that as x approaches negative 3 from the left, so this spot right here approaching from the left, we would say that f of x approaches negative 10, and as x approaches negative 3 from the right, so this spot over here on the right, f of x approaches negative 10, and then we can see that both sides are equal, so overall we say that as x approaches negative 3, f of x approaches negative 10, okay? And this is actually a limit, okay? So using limit notation, it looks like this. We would say the limit, L-I-M, as x approaches negative 3 from the left of the function, you don't actually need to write out the function, equals negative 10. And we would say that the limit as x approaches negative 3 from the right of the function equals negative 10. And these together are called one-sided limits. Okay, and then we would say that overall, the overall limit is that the limit as x approaches just negative 3 of the function equals negative 10. Okay, and here we say that the limit exists. Okay, and this leads us to the definition of limits. And so I'm going to go ahead and I'm going to write that in, and you should pause the video and you should make sure you fill in your note at home as well. Okay, so here's the definition of a limit. So for a limit to exist, okay, like the one does above, we need the left limit to exist, we need the right limit to exist, and then we need the left limit to equal the right limit to equal some number. Again, L is any real number, so any real number. And if any of these conditions are not true, then we say that the limit DNE does not exist. Okay, so let's take a look at some questions and see what they look like. Okay, so here's your first example. This is a piecewise function. It should be drawn perfectly. I'm not quite sure what happened with the PDFs there, but first question for you, is it a function? Okay, place your guess. Make sure you're thinking about what you would have guessed. Yes, it's a function. Why is it a function? Because it passes the vertical line test, right? Or every x has one y value, right? That's your vertical line test from grade 11, okay? F at 1, what do you think f at 1 equals? Assuming every box is 1 here, like we have the scale, this is f at 1, this is the closed dot, so f at 1 equals 0. Okay, but now let's take a look at the limit. So to determine, this is an overall limit. Ultimately, we want to determine what this equals. So to determine the overall limit, first we have to take a look at the, so as x approaches 1 from the left of the function, what does that equal? So take a look. The left, here's 1 right here. So the left of 1, we have the y value is 0. Okay, so that limit equals 0. And then let's look at the limit as x approaches 1 from the right of the function. So see if you can figure out now where I'm looking. So here's 1, here's the right, this is the function on the right, and as we approach 1, what's the y value there of the function? The y value is 1. Yes, it's an open dot, but that's why this is called a limit, because we're getting closer and closer and closer, and it's approximately 1. So here, since the limit as x approaches 1 from the left of the function does not equal the limit as x approaches 1 from the right of the function, then overall we say that the limit as x approaches 1 of the function does not exist. Okay, so pause that, take a look, make sure you can see what those limits are, and let's try the next example. Okay, so I have one more for you to see. Note, this is again a piecewise function that I want you to take a look at, and I do want you to actually graph this function yourself, okay, so this function right here. So to save time, I am going to pause the video, and then I'm going to graph that function, so do yourself a favor, pause the video yourself, and see if you can graph that function on your own, because if we ever do have any sort of an assessment, I would expect that you would know how to graph that function, okay, so pause the video. Okay, so take a look at my graph here. I used a scale of 2. I have this as my parabola right here in red up until that point. Now this is a closed dot because it's the parabola that is equal to 4, that includes 4, versus the line that is just less than, right? So our line starts here and then continues in that direction. Use the dotted lines if you need, or erase the part of the function that you don't need after all. So here we're going to look at two questions. We're going to start by looking at the limit as x approaches -2. Okay, so -2 is right here. And just to clarify, I think you can see that that should be the point right there. So to look at the limit, we need to look at first the left limit as x approaches -2 from the left. Okay, so -2 from the left, I'm looking right here. This is the function on the left, and the value of the function is 2. And then I'm going to look at the limit as x approaches -2 from the right of the function. And so again, I'm looking over here now. I'm looking on the right, just to the right of -2, and you can see that the value is also 2. And so because the left limit equals the right limit, we can say they both exist and they both equal a real number. We can say that the overall limit as x approaches -2 of the function equals 2. Okay, but now let's look at 4. So let's look at what's happening when x equals 4. Okay, again, see if you could do this yourself. What's the limit as x approaches 4 from the left? And what's the limit as x approaches 4 from the right? Can you see it? Okay, from the left, we can see that just to the left, the limit is down here, so I believe that would be -10. And if we look to the right, this is the right of the function, and you can see that the limit here is right there. Okay, that value, which is -6. And so then hopefully you can see that since the limit as x approaches 4 from the left of the function does not equal the limit as x approaches 4 from the right of the function, then that means that the overall limit as x approaches 4 of the function does not exist. Okay, so hopefully that makes sense to you. There's going to be a sheet to practice, and there's a few questions in the textbook. They're fairly simple once you get the idea and once you can visualize it. So definitely spend some time practicing to make sure you can see it. And I'll see you later in our online classroom, and you can bring your questions, bring your pictures, anything that you need, and we'll try to figure that out there together. Thanks. Have a good one.